Hello. The question that we're going to try and answer today is how can we solve trig equations? Okay, and as you watch the video, be sure to pause at any time that you need to write things down or anything like that. Well, whenever we're solving trig equations, there are two main steps. First, we're going to solve the equation for the trig function. Okay, so we're going to isolate that trig function. If we need to factor, we'll factor. And then we're going to look at the unit circle and find the values on the unit circle. Okay, things to note is if the x has this little degree symbol, your answer needs to be in degrees. And if it's just an x, then our answer is in radians. Okay, so let's just jump right into it. Here we have 2 sine x minus 1 equals 0. So I'm going to get the trig function by itself. Just like any other equation, I'm going to add 1 to both sides. I'm also going to make this pen a little smaller. So 2 sine x equals 1. Divide both sides by 2. So the sine of x degrees is 1/2. Okay, so now we see that sine of x in degrees equals 1/2. So I need to look at any time on the unit circle. If I took the sine of some degree, I would get 1/2. So we have to remember that the sine is the y value. So I'm going around the unit circle. I see that I have a y value of 1/2 at 30 degrees and a y value of positive 1/2 at 150 degrees. So this happens twice. This happens at square root of 3 over 2 1/2 and negative square root of 3 over 2 1/2. So my answers are that they occur at 30 degrees and 150 degrees. Now, if you were to think backwards on this to what we had been doing, that's just like saying this, what's the sine of 30 degrees? You would have gone to 30 degrees, looked at the y value, and it's 1/2. All right. So let's keep going. Our next example is the cosine of x plus the square root of 2 equals negative cosine x. Okay, so I'm going to isolate. I'm going to subtract a cosine x from both sides and get the square root of 2 equals negative 2 cosine x. Now to get the cosine by itself, I need to divide both sides by negative 2. So negative root 2 over 2 equals the cosine of x. Alright, and we remember that cosine are the x coordinates. So I'm looking for any x coordinate of negative root 2 over 2. So around the unit circle, I'm looking for any time this occurs. So go around. Negative root 2 over 2 in the x happens at 135 degrees. But notice that we're not talking in degrees this time because x is not in degrees. So this occurs at 3 pi over 4. And the only other time that negative root 2 over 2 happens in the x is down here at 5 pi over 4. So this happens twice at 3 pi over 4 and 5 pi over 4. Now so far we've only dealt with finding x and y coordinates. With tangent it can be a little bit trickier. So we're going to solve it just the same way as we've been doing. We'll add 1 to both sides. And notice that we're working in degrees this time. Divide by 3. So tangent squared x equals 1/3. And here to get just tangent x, I'm going to have to take the square root of both sides. So this is the tangent of x is equal to, whenever you have a square root of a fraction, it's the square root of the numerator divided by the square root of the denominator. So 1 over root 3. Now we don't leave square roots in the denominator, so I'm going to multiply this by root 3 over root 3. So I'm looking for the tangent of x to equal the square root of 3 over 3. So I'm thinking back to tan, and I know that tan is y over x. So I'm looking for whenever the square root of 3 over 3 will occur whenever I divide y by x. Well, with the numbers on the unit circle, this is only going to occur, like this y over x will only equal the square root of 3 over 3 whenever we take 1/2 and divide it by the square root of 3 over 2. Okay, so I have to look for the points square root of 3 over 2, 1/2, or they could both be negative because that'll still give me a positive square root of 3 over 3. So negative square root of 3 over 2, 1/2. And on the unit circle, that occurs here at 30 degrees. I've got the square root of 3 over 2 in the x and the half in the y. I'm sorry, and this is also negative. And then this, where they're both negative, this occurs at 210 degrees. So my answers here would be 30 degrees and 210 degrees. And again, just feel free to pause or rewind this video, whatever you need to do to make sure that you're understanding each step. Okay, so the first few steps of this problem should be pretty familiar now. We're going to add 6 to both sides to get 8 secant squared x equals 16. Divide by 8 to get secant squared x equals 2. And now we have to take the square root of both sides to get secant. So now secant x equals the square root of 2. So I'm looking for when 1 over x, because secant x, let's think about this, secant is 1 over x. Okay, so I need to know, when does 1 over x equal the square root of 2? Well, that occurs whenever we have 1 over the square root of 2 divided by 2. So since that's just the x, the square root of 2 over 2, I'm just looking for anywhere on the unit circle where I have an x-coordinate of square root of 2 over 2. Okay, so it's also positive, so here at root 2 over 2, and I'm answering in radians because the x doesn't have a degree, that occurs at pi over 4, and here at 7 pi over 4. So my answers are pi over 4 and 7 pi over 4. Alright, so now let's get crazy. Okay, here I have 2 sine squared x minus sine x equals 1. Since I have a sine squared and a sine, I'm going to have to do some factoring. So I'm going to bring everything to one side of the equal sign. 2 sine squared x minus sine x minus 1 equals 0. Okay, now, once we're thinking about how to factor this factors down to 2 sine x plus 1 times sine x minus 1. Okay, and you can get there using the divide and slide method or guess and check, whatever. You can check yourself here, though, just by foiling this out. 2 sine x times sine is 2 sine squared. Negative 2 sine plus a sine is negative sine, and 1 times negative 1 is negative 1. Okay, so I'm going to set each of those equal to 0. So 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. So now I've just got two equations. 2 sine x equals negative 1. So I've got sine x equals negative 1/2, and sine x equals 1. So I'm looking for any time when the y is negative 1/2 and when the y is 1. So for y is equal to negative 1/2, I have here at 11 pi over 6 and here at 7 pi over 6. 7 pi over 6, 11 pi over 6. And now for whenever y equals 1, that only occurs one time, okay, at pi over 2. So this problem had 3 solutions. Alright, next we have 2 cosine squared x equals cosine x. So again, we're dealing with cosine squared and a cosine. So let's get everything on the same side. 2 cosine squared x minus cosine x equals 0. I could do this problem just by factoring out a cosine x from each term. So I'm going to factor out a cosine x, and I'm left with 2 cosine x minus 1 equals 0. So now I set each of my factors equal to 0 so I can solve. Cosine x equals 0, and 2 cosine x minus 1 equals 0. So now that we've done this a few times, we know we're going to add 1 divided by 2. I'm looking at cosine x equals 1/2, and cosine x equals 0. So since it's cosine, I need any time that I have an x-coordinate of 0 or an x-coordinate of positive 1/2. Alright. Well, an x-coordinate of 0 happens twice. See, I've got an x-coordinate of 0 here and 0 here. So I've got pi over 2 is a solution, and 3 pi over 2 is a solution. And then an x-coordinate of 1/2 occurs right here. Here's my x of 1/2. That's at pi over 3. And then right here I have an x that's 1/2 at 5 pi over 3. This problem had 4 solutions, just because I was looking for any time that an x-coordinate of 1/2 or 0 occurred on the unit circle. Alright, here we are again with our last example. We're dealing in degrees. We have a cosine squared and a cosine, so I'm going to be factoring. So I'm going to move everything to one side. 2 cosine squared x plus 3 cosine x plus 1 equals 0. Now, after using divide and side or guess and check, whatever, we can factor this down to 2 cosine x plus 1 times cosine x plus 1. Sorry, my handwriting's getting worse. Alright, now set each factor equal to 0. 2 cosine x plus 1 equals 0. Cosine x plus 1 equals 0. So I'm looking for when cosine of x is equal to negative 1/2 after subtracting 1 and dividing by 2, or when cosine of x is equal to negative 1. So we're talking about cosine, so these are x-coordinates. I'm looking for an x-coordinate of negative 1/2 or negative 1. Okay, well the negative 1/2, that's going to occur twice. I've got an x-coordinate of negative 1/2 here at 120 degrees and here at 240 degrees. So 120 degrees, 240 degrees. And an x-coordinate of negative 1 only happens once here at 180 degrees. So almost every single time you're going to get multiple answers. Okay, whenever you're factoring, you're looking for 3 or 4 answers, typically. All right, and that's our intro to solving trig equations.